A very good morning, everyone. This is Venkat from Genetics Coimbatore. On behalf of Genetics and Famic Technologies, we welcome to all of you for the Automation Studio webinar series. Genetics is proud to be an Indian manufacturer of automation products, providing innovative solutions for various industries and offering didactic systems for technical education. So we established in 1977, and our R&D division is approved by the DSIR, and we boast in-house tool room facility for tool and die machinery. As an integrated manufacturing system certified company, we have a pan-India service facility with over 15 branches across the country and 4 overseas offices in USA, Germany, Africa, and Dubai. Our global presence includes 400 plus support engineers and 150 plus dealers and stockists, serving over 1,000 OEMs and 17,000 direct customers. So we are also authorized distributor of Automation Studio in India, and we are excited to have Mr. Madan Patil from Famic Technology with us today to lead the session. So we have a series of webinar planned on various topics throughout this month. If you have any questions, please feel free to write in the chat box, and we will ensure that it is addressed. Now I invite Mr. Madan Patil to start the session. Thank you.
Thank you, Venkat Prasad. I hope my screen is visible and I am audible.
Yes, you are.
Yes, you are.
Okay. Just a second. Just a second either. Okay. Sorry. Good morning, everyone. Before I start with the actual presentation of the software with renewable energy topic, I would like to brief about our company, Famic Technology. So, our company name is Famic Technology. We have founded in 1986. We are ISO certified, and currently we are more than 130 plus engineers and software specialists. Famic Technology is leading the industry by designing world-class trade-oriented tools in the field of fluid power, electrical engineering, industrial automation, and custom software development. We have 3 offices in worldwide. Our headquarters is in Montreal and 2 branches, one in Mannheim, Germany, and another in Pune, India. So we have in-house expertise in software development, engineering, industrial automation. In software development, we have expertise in software engineering, database design and support, network support, multimedia application, and real-time systems. In engineering, CAD CE system, pneumatic systems, hydraulic, mathematical modeling, electrical system, automation engineering, instrumentation and process control, and training. In industrial automation, PLC programming, SCADA system, electrical control, process simulation, robotics. So we have 4 products. First is our Automation Studio Professional Edition, which is used to create, analyze, troubleshoot, and validate their multi-technology circuits, and it is used in industries. And Automation Studio Education Edition, it is used to train future technicians and engineers on hydraulic, pneumatic, electrical robots, PLC systems to train their engineers, and it is used in colleges, engineering colleges, institutions. And another is Automation Studio Live Manifold. It is used to complete hydraulic manifold software solution for design, coating, and prototyping. And we have another software in Anden Studio, which is complete solution to optimize your production, and it is more related to Industry 4.0. Our objectives are: we believe in long-term relationship with the customers. We give effective support by phone, email, and online. We have dedicated representative for each account, and we have support material to for training videos, demonstration files, quick start guides. We are going to see on today's topic on educational edition some milestones by Family Technology. As I earlier told you, Family Technology founded in 1986. Before we known as HydroSim and NeoSim in 1989, and in 1996 we started Automation Studio Windows version, and with the help of our customers' feedback and our engineers, currently we are in Automation Studio 9.0 and Anden Studio version 3. Uh, it is a multi-technology software and programs. So what is a multi-technology software? As you can uh, do hydraulic manifold, pneumatic, component sizing, bill of materials, teachware, FMEA, workflow, ladder logic, block diagram, robotics, electrical control, mechanical parts. Everything is we can do in one single technology software. In single software, it's a multi-technology, and our software is fits in multiple programs like mechatronics, industrial maintenance, aviation maintenance, diesel, agriculture, and heavy duty mechanics, electrical, robotic and automation, renewable energy, electromechanical and technology, HVAC, marine technology, automotive. Key benefits of Automation Studio. For students, how the Automation Studio is useful for students, teachers, and schools. For students, they can validate their theories, study in the class, and they can learn by simulating the circuits on software. And for teachers, they can facilitate demonstration of system interactions, and they can teach their book circuits in the software and easily integrate into the course content. For schools, it eliminates the need to purchase single technology software as it is a multi-technology software, and it can be used in conjunction with other departments. Now, teachers can give e-learning or remote access to the students. They can access Automation Studio and students can access the uh, Automation Studio from schools or from home, and teachers can give their homework to the students, and they can work from the home, and they uh, and as per the e-learning or remote access, you can create the priorities to the teachers and students. They can modify the circuits and give the examples. Um, we have international presence. We are available in 13 languages in more than 150 countries, and it is used in high schools, career centers, colleges, universities, workforce development. Uh, we have four publications in Automation Studio software. From these books, we have uh, ready to simulate circuits are available in the Automation Studio. And for example, the circuit is created from the fluid power by Anthony Esposito, and there are available schematic from these books, and they can create or ready directly simulate the circuits and learn from them. Now we have created interactive exercises. Students can go into teachware and access these circuits, and they can learn from these circuits, and teachers can give these exercises to the students. uh, we have already created the circuits, or teachers can create their own circuits and give the homework to the students, or or you can create your own circuits, and it is easily customizable. uh, digital twin of your own equipment. As colleges have hardware kits, and this is a hydraulic or and pneumatic hardware kits, and it same hydraulic circuit we have created in Automation Studio, and you can connect this both the circuits from software to the hardware to through the OPC server client, and you can monitor your hardware through our software. We have illustrated libraries for PLCs, AC/DC, and motor control, hydraulic, pneumatic, electrotechnical, and there are three ways to create, simulate, and troubleshoot. Uh, for electrical, PLC, pneumatic, hydraulic, and multi-technology, three ways to create circuits like symbols. These are the ISO symbols, and you can create from the 2D diagrams. And second is illustrated components. We have created illustrated components, and you can see actual visualized components in there. And recently we have developed virtual trainers. As you have trainer kits, you can replicate that same circuits in the virtual trainer kits, and you can access that. Virtual trainer plus versus hardware trainer. Here are I have two videos for pneumatic trainer kits. Here you can see small video of that, as he is connecting the hardware kit through the pipes, and here you can see same circuit is creating with the help of Automation Studio. So you get the idea of how Automation Studio is same can create that circuits same like hardware kits. Okay, so you have seen the video. Now, benefit of virtual plus hands-on experience of software. So for example, if you have hardware only, then only two students per unit can work on that, and they can uh, it is a more expensive option for them, and the students also don't get the time to uh, work on hardware kits. And if you purchase hardware plus Automation Studio, example two hydraulic and electro hydraulic trainer kits or and 20 user Automation Studio, they can take hands-on experience, hands-on training with equipment. They can virtually test, troubleshoot, and validate circuits from their books. They can introduce a student to circuit design software, and it is a less expensive option. We have most important feature of the Automation Studio is manufacturer's catalog. We have ready to simulate pre-configured components from the manufacturers of from these manufacturers. Like Arvados, Belly, Bimba, Eaton, Danfoss, Hengley, Oil Gear, Parker, Rexroth. This is the interface of Atom virtual sorry manufacturer's catalog. Here you can see uh, it can be test the components from here, and students can understand how the components are working and their how it works. So it is a best feature for students also. Partial list of industrial clients. We have presence in aerospace, agriculture, energy, forest, construction, defense, metallurgy, transport, system integration, handling, and companies like Airbus, NASA, John Deere, Orano, Larsen and Toubro, JCB, China, Honda, Hydraulic, and Manito. Um, so let's see the demonstration of the software. We will move to the software. This is the Automation Studio symbol. Automation Studio 9.0. When you start the Automation Studio, you will get this window, and we have to select the template for working. Here are the in left side there is a library explorer where all the technologies are available like hydraulic, pneumatic, proportional pneumatic, environmental and control, instrumentation and process control, ladder logics, electrotechnical IC, NEMA standard, electrotechnical one line, HMI control panel, robotics. So when you click on the each technology, you will get all the symbols, and these all are the symbols where you can create your circuits. So today we are going to see renewable energy. For that we have library explorer. We have to open library from we will take electrical motor control library. Here we have get the electrical motor control renewable energy library. From here we can uh, drag expand the library and get the components from here. So firstly we are going to see the example of solar energy. For that I will take one I will start with the creating circuits. Firstly I will take ambient generator. uh, we will take ambient irradiant generator. Sorry, before I start the working I need to change the standard diagram to electrotechnical diagram to work it. It should be compatible to the electrotechnical. We have taken irradiant generator. Now we will take photovoltaic cell. We will take photovoltaic generator 24-volt polycrystalline. Now we will take one rheostat. Passive rheostat. I will connect it. For connecting this circuit or components, we have to just click on from the red dot icon and connect these dots. Then we will get connection between the components. So I have connected the rheostat to the photovoltaic cell, and now I will give the we will just give simulation. We will take component dynamic measuring instrument where we can check the working of the components. I will take current, no, dynamic measuring instrument. Voltage. Now when I start the simulation, and okay, so before start we have to change the properties of the components like solar data. We have to make it to 100 from 1000 to 800. We will take change the data. Mhm. We will make it 60 panel slope of the panel 60. Now we will, yeah, now it's working. And when we change the rheostat, here are the we are getting the readings. These are the dynamic measuring instrument. We have y of x and y plotters also where we can get the graphical presentation. We will take y of x plotter. we will track this current and voltage. Here we have taken electric current to electric potential. Now when I start the simulation, I will pass it to there. Now when I slowly increasing this setting point to 0, we have taken the readings we are getting like this. As I am decreased the speed, we have get the readings. So this is the normal uh, solar panel and a rheostat. Now we will add one battery here to check the battery capacity. We will take 24-volt battery. I will delete these connections. Now I will connect these batteries. Sorry. Okay. So we have connected the battery. Now we will connect dynamic measuring instruments. We will take state of the charge, efficiency of the photovoltaic cell. We will measure the current here. We have options like average current, TRMS current. We will take current, this wire current. Now we have seen the Y of X plotter. Now we will take one Y of T plotter. Now here we will take state of the charge. Sorry, we will take battery, state of charge. So we will get waiting percentage here. Now when I start the simulation, now here the battery is the simulation is started and our battery is at 0%. But when I start the increasing the setting pressure, we can see the battery's work percentage is increasing. And when I click on the Y of X plotter, you can see our battery is getting charge. And now it's from 0 to it's coming to the 30 and it's increasing. And when I change the irradiance, I will change to 600, and here at 30 slope I will change. So you can see the battery percentage is now getting slowed down and charging is getting slow. Likewise, we can see the battery percentage and how it is charging from the solar. We have seen that. Now um, when I change the rheostat, you can see battery percentage is decreasing and it's fluctuating how fluctuated. Now it is working in this way, but in real way we use the charge controller in between the circuits. So now we will take one charge controller. We will take 24-volt MPPT charger. Okay, I will delete these connections and I will connect MPPT charger with it. It connected. Okay, now we will again take two node dynamic measuring instrument to check the voltage of the photovoltaic cell. We can component dynamic measuring instrument, current. Now when I start the charging, here when I increase it, you can see our charging is getting increasing in from 50%, and here I will, when I change it here to 200, I will change the radians to 200, and it's at 10%. Then you can see our charging is getting decreasing, and MPPT charger is working, taking the measurements. Here you can see our battery percentage is get increased, and then it's going to decrease. We can use a cursor here to check the measurements, the percentage at the points. It's went to 55%, and then it started to decrease as I changed the radians from 60 to 600 to 200. So when I increase its photovoltaic to 30, or I will make it to 60, and irradiance at 800. So then again my battery level will start increasing. It's dropped to the 38% and started increasing the battery percentage. It is one of the example of solar energy. Now we will move to the wind energy connections, and we will see how wind energy is working in Automation Studio. I hope you have uh, understood how its solar energy is working. We can get the points from the battery and how it is working, battery connections. Now I will delete it all, close project, and now I will create one new project with for wind energy, electrotechnical diagram. For wind energy, we will take wind generator here. I will change the page setup to 1117. Now I will take wind turbine, fixed pitch blade angle wind turbine. Now we will connect the circuit with drive and transmission connections like shafts, mechanical multi-gauge, gearbox, clutch. So firstly I will take multi-gauge measuring instrument multi-gauge, and I will connect it here, which will I get give measurements from RPM, kilowatt, and DAN. So now I will take one shaft. Now we will take one gearbox. We will get the gearbox from generic component. In generic component, we have drive and transmission elements library. From that, here are measuring instruments, power transmission, gearbox, power units. Yeah, in transmission, we will get gearbox. We will change its parameters, direction to from negative to positive. We will take clutch here, give the connection. Sorry. Yeah. Yeah. Now we have connected the gearbox. Now we will connect no gear one no brake with shaft to the gearbox. Yeah, here we have connected it. Now we will connect one more shaft here. We will again connect mechanical multi-gauge. Then we need one motor. We will take motor control. Motors, AC motors. We will take one three-phase permanent magnet synchronous motor. We will change its orientation from this side and connect it. Okay, our motor is getting connected. Now we will take one protection device. From protection, we will take circuit breaker 3 pole. Circuit breaker 3 poles. We need one loads from resistive load. 3-phase resistive load. Yeah. Here we have taken all the components which we have required. Now we will connect this circuit. So we have connected the circuits. Now we have to change the properties from that. Friction coefficient 0.1 and moment of inertia 10. Now we will change the properties of motor from default machine 3.0 kilovolt, but we will convert the create motor to the 3.0 kilowatt and its parameter load parameter is parameter slider. So we can at the time of simulation we can slide and change the parameters. So we will start the simulation. Before that I will connect the measuring instruments like dynamic measuring instrument. Okay, no dynamic measuring instrument. Voltage. voltage. Okay, so when I give its wind speed is 0, when I give the wind speed increase, our as I have increased the wind speed, our turbine is getting increasing, and here RPM is showing at 68.3 RPM. When I click on the clutch, we are getting the kilowatt is increased from zero point 0.1. Now when I increase it, and the parameters are getting changed. Here the battery is the current is passing to the battery, and when I click on the, here you can see the voltage is varying, and when I click on the on button, we are getting the voltage. So this is the one example of wind turbine energy. Now we will see some videos. Catalog manager. From demo files, I will show you some. Here is the one example of in gear wind turbine hydraulic. Here you can see one hydraulic blades, how it is working, and the gearbox, how it is converting the wind speed to the electricity. It is the auxiliary uh, hydraulic pump can turn the rotor in absence of wind. So we get the energy from here. And one more example from wind turbine. Uh, how it use the wind speed button to change the wind speed, and the blade's angle of attack adjusts it automatically from the system. The circuit behind that it is showing here. Wind turbine adjust to face the wind. One more example of BMS battery. I will search it directly here from here. Vehicle BMS one. It is not renewable, but it's related to battery. So I will show you. When we turn on the voltage balancing function and activate the loads, you can see observe the change in decrease or increase in the battery capacity. Both processes can be seen. So I have completed. I am done from my side from the presentation. If you have any questions, you can type in chat box. We will try to address that. Do we have any questions?
Yeah, Manthan. So thank you for the presentation. If anybody has any question, you can just put the questions in the question pane. Okay, so we will address it. Okay, I guess there are no questions. So thank you very much for your for joining the webinar. Okay, Venkat, do you have anything to say? Hello Venkat, are you there?
Yeah, sir, I'm there.
Yeah, so we are done with the webinar.
Fine, sir.
Okay, then
Okay.
so
Yeah.
can we end?
Sure, sir. We'll close. So hope everyone had a great session today. Thank you, Mr. Madan Patel, for the wonderful session today, and also thanks to the entire FAMIC team for the wonderful webinars. So we have the next webinar day after tomorrow. So if someone is not registered, please do register, and had a great learning on that. So if you have any doubts regarding the products or any doubts, you can contact Genetics or FAMIC. So we'll be very happy to address your questions. So thank you all. Thank you. Have a great day.
If you have any questions, you can you can mail us on these mail IDs to Saurabh Lakmapure or me. You can take the mail IDs. Thank you for joining.
Thank you, sir. Thank you all.